All right, it's Mr. P. with Algebra 2. This is Unit 3, Topic 1, SLT2. First day. Once again, we're getting into more of an intro of sine functions. And starting off with a warm-up, this is very much like what we had done in the last video. So we're trying to find the distance that a merry-go-round is at all these positions away from this wall. So it says it has a radius of 8 feet, and it has a center that is 15 feet away from the wall. So knowing that the center is 15 feet away from the wall, then I know that position A is also 15 feet from the wall. And so is position E, because A and E are parallel to the wall. So therefore E must also be 15. Now I can also find two other positions fairly easy, which is position C, because if this is 15 and this is 8 more, and that makes 23. And if I want to find position G, then I know the center is 15, but if I go backwards, the radius, 15 minus 8, gives me 7. So G is 7. Now, in order to find the height of position B, what I need to do is find the height of this right triangle. So if I can find this angle, and I'm trying to find the height of this triangle, and I also know that this radius is 8, because the radius is the same length in all directions. So therefore, sine of this angle is equal to x over 8. So I just need to find what's that angle. And the way to find that angle is to take a full circle, which is 360 degrees, divide it equally amongst 1, 2, 3, 4, 5, 6, 7, 8 equal parts, and that will give me my answer. So, let's see, 32 with 4 left there, 45 degrees each. So that means it's sine of 45 equals x over 8, multiply both sides by 8, and then I will find x. So in my calculator, 8 times, there we go, 8 times sine of 45. Make sure once again that you are in degrees and not in radians, and that's going to give you 5.7, give or take. I rounded it to the nearest tenth. All right, so now if position B is 5.7 above that spoke, and the spoke is 15, so I'm just going to add those two together, and I get 20.7. If B is 20.7, then D is also 20.7. And remember from the last video that this triangle is an exact mirror image of the other triangle, only it's 5.7 below the center height. So it's 15 minus 5.7, which gives you 9.3. So if H is 9.3, and so is F, because these two positions are equal height because they are the exact same triangle. That triangle and this triangle are perfect reflections over this spoke right here. Or you could say like what would be the y-axis. Okay, so now we're going to get into talking about time. So it takes 12 seconds to complete one revolution. So what I need to do is figure out how many degrees is that per second? So if I divide, so now we're talking about time instead of breaking it up into equal amount of sections. So that gives me 30 degrees per second. So after 1 second, I've gone 30 degrees. After 2 seconds, I've gone 60, then 90, then 120, 150. And now I would just continue this pattern until I get all the way down. So that would be 210, 240, 270, 300, 330. Now 360, that makes sense because that's one full circle, and after 12 seconds, I've gone one full circle. So this would be 390, and this would be 420. Now, calculations. So in this case, we're being told that the radius is 8. This is the same question as we were just doing, and the center of the ground was 15 feet. So I'm going to multiply. This is the formula. So it's always radius times sine of the angle plus the center height. Now, finding the angle of angles right here. So that's radius, which is 8, times sine of 30, plus the center height, which is 15. And I'll just keep doing that all the way down. So 8 times sine of 60 plus 15. And then 8 times sine of 90 plus 15. And then I can simply put each one of these in the calculator and put it right here. Now, you can kind of do the exact same thing in your calculator. If you go to y equals, you can put this equation in. So just put in x for theta. So remember, theta is just the variable that we use to represent missing angles. So it's basically just like using x for missing heights of a triangle, or missing sides, or anything. So I'm going to put in for my y equals, I'm going to put in 8 times sine of x, end parenthesis, and then add the center height, which is 15. And that's going to give, that's this equation right here. Now, if I press table, then I'm going to see a table that looks like this. But that's not exactly the most helpful because we're not doing every single degree, or we're doing every 30 degrees. Now, keep in mind this is, so x represents the degrees. So that's what this number is. 30 represents 30 degrees. So what I'm going to do is I'm going to go to my table setup. I'm going to have it start at 0, and I'm going to have it go by 30s. So it kind of looks like that. So table setup, and then you do that. And then if you go back to the table, which will look like this, and what you'll have is basically all of the answers. So just copying right off my calculator, after 30 seconds it says the height will be 19, and then it's going to be 21.9. And then after 90 seconds, it's going to be 23. And then it's going to be 21.9 again. And that makes sense because it's kind of like the Ferris wheel. So the height here and the height here are going to be exactly the same. They're going to be the exact same. So after a certain amount of time, and then after another amount of time, it's going to be exactly the same height. And then it becomes 19 again, and then it becomes 15, which is the center height. So after you've gone halfway around a circle, it's exactly the same height. And I'm going to keep going. So this is going to be 11 at 210 degrees, and then 8, and then 7, and then 8 again. Now, it's actually 8.07, but I'm just rounding, and then 11, and then 15. Now that makes sense because after a full circle, you're back where you started. So you're once again back at the same as the center height. So you can kind of see the patterns here. So these two are the same, these two are the same. And then these two are the same, and these two are the same. And these two are the same. So it's obviously going to be the same because you're on the same positions like this on the circle. Okay, what happens to the sine values when the angle is between 180? Okay, so this is just two ways of doing the exact same thing. Mary and Javier both use different methods to calculate the distance. After 7 seconds later, they both correct. So I kind of showed you that we're just doing radius times sine of 210. Now 210 and sine of 30, which is this angle right here, and sine of 210, which is this angle. Now keep in mind, this is just giving us an idea that this angle and this angle are exactly the same angles. So this one would be that much above the center, and then this one would be just that amount below the center. So I'm taking that negative answer and adding to the center height, which gives me 11. Gives me the exact same answer. So what happens to the sine values when angles between 180 and 360? The answer is it become negative answers because once you've gone past 180 degrees, now you're that much below the center height. So you have to take it away from the center height. So that kind of makes sense in the context of the question. So this time you're taking away from the center height, which is 15. Can you come up with another equation to model the merry-go-round in position after t amount of seconds? Okay, so it's radius multiplied by sine of d, which I'm going to use to represent the degrees per second, multiplied by t amount of seconds plus the center height. And that'll always work. And we'll use that a lot in the next couple of videos. In a Ferris wheel, a radius has 35 feet and the center is 42 feet. All right. What do we need to know? What if it takes 30 seconds to complete one rotation? Well, we need to know how many degrees that is per second. That's 360 degrees in a full circle divided by 30 seconds to get one complete revolution. And that's going to give me 60 left there, so 12 degrees per second. How many seconds will it take to be at the point furthest away from the ground? The point furthest away from the ground is right here. So that's like going 1/4 of the way around the circle. So if it takes 30 seconds to go all the way around, you multiply that by 1/4 of the circle, and you end up getting 7.5 seconds. Now, another way of thinking about that, well, if it takes 30 seconds to go all the way around, then it takes 15 seconds to go halfway around. And to get halfway to 15 would take 7.5 seconds. Same answer. What is the distance from the ground after 10 seconds? So now we can use our formula. So we already came up with the formula on the last page. So it's going to be radius times sine of degrees per second, which is 12, multiplied by 10 seconds, plus the center height, which is 42. All you got to do is put that in the calculator and press enter, and you've got your answer. 35 times sine of 12 times 10 plus the 42, and I'll show you before I press enter. Actually, no, I'll press enter first. And there you can see how I put it in, and you can see what I got as the answer. So it looks like it has a height of 72.3. Now, we don't have to add anything to any center heights or anything because that's all in the formula. Because you remember, whenever we had sine of an angle, it equals x over something, we multiply both sides by the radius. Well, that's the reason why it's the radius times sine of the reference angle. Or actually, not the reference angle, the standard angle. And then you add the center height because that's either how much it's above or below the center, so therefore we add the center height. So this formula basically does everything we've been doing in the past in the last video, all at the same time. And the last one. So what do we need to know? Merry-go-round has a center that's 25 feet away from the wall. It's 17 is the radius, and it takes 24 seconds to complete one rotation. So we need to know how many degrees that is per second. So 360 divided by 24. 360 divided by 24 gives me 15 degrees per second. How many seconds will it take to be the furthest away from the wall? So that would be 24 seconds for a complete revolution, multiplied by 1/4 of a movement. 24 divided by 4 is 6 seconds. How far away from the wall will you be after? 14 seconds. So after 14 seconds, we put that in our equation. So that's radius times sine of degrees per second multiplied by the amount of seconds plus the center height. And voila, we've got our answer. Sine of 15 times 14. Now keep in mind, when you're doing 15 times 14, all you're really doing is figuring out the angle that you're going all the way around. In this case, 15 times 14 is going to be a number that's negative, so it's going to be adding something that's negative to the center height. And it's going to be 16.5. And there we go. Please give it a like if I helped you learn something about how to use sine functions when using time. And watch for future videos. Thanks again for watching. Have a good